Okay, I guess no minute of silence today. Alright, good morning guys. First thing we're going to focus on is our worksheet from last class, which was assignment 36. I believe it had 17 questions on it, and between the class time and homework time you spent on it, I'd ask you to feel good about 10 of those. So very likely within you trying to finish up and get comfortable with at least 10 of those, you found a couple that you were not okay with. So in just a second here, I will start off with those questions, and if I guess you didn't find any and you were doing okay, you can go ahead and move forward on trying to finish that up. And then the other two handouts I had you pick up. Number 30 is the unit review. So laid out kind of the same way as our first two. Remind you that implicit is a big topic and gives you a few questions to practice. And then at the bottom, it shows you where you can get even more practice if you still feel like you need it. On the second page, it's got 3 related rate questions, and then a ton of different places you could go practice related rates if you feel like you need more. And then a couple questions on derivative of exponential functions, which should just take you just a second, but also extra practice available there. And then one practice FRQ on the back. The entire back page has all of the answers, so there's no questions to work out on that. So that's all Unit 3 really is implicit, which we already spent a full class and a half on. Related rates, which we basically spent 2 full classes on. And derivative of exponential functions, which took us about 5 minutes to do. So as you finish up 36, I would like you to move forward towards the test review and start on that when you get there. The other handout you picked up today is 37A, and 37A, this one is optional. I will not take up 37A for a grade, but like I have been mentioning lately, FRQs are usually the hardest part of your AP exam, which means they should be the hardest part of your class exams. And the only thing I can do to make those a little bit easier for you is to give you some extra practice. So if you're willing to do those, the FRQ that you see on the test should have some very similar parts and pieces. It's asking some of the same things. Not the same numbers, it won't be the exact same questions. Maybe not every part is on that, but if you do practice those 3, that optional work, you should feel more comfortable with the FRQ on your test. Now, I do have the late work policy reminder and stuff up there, and you can see that under upcoming assignments, it's had the date for next class. We are actually going to adjust that a bit, not because you should need more class time. Well, it's not that you don't need more time for implicit and related rates, but obviously the more time we spend on this stuff, the less time you're getting to spend on the next topic, which you may need more help on. It just depends. Everyone's different. But I have an activity. It's a circuit on calculator usage stuff that we need to do at some point anyway. So I am going to change our next class from the test to doing that, because it doesn't really matter when we do that, and then that buys you a little bit more calendar time to study for the test if you need it. Now of course, if that just means you procrastinated that much more, then it's not doing you any favors. But if you study a little bit and prepare like the test is Tuesday, which is when it was planned to be, and then it actually ends up being on Thursday because we'll do something else on Tuesday. Tuesday won't be test review. Today is set aside for test review time. If anything, that should give you more time to prepare, especially since next Wednesday some of you guys won't have as much school stuff to do. Next Wednesday is the PSAT test, so unless you are a sophomore and have to take it, or you're a junior and you chose to take it, you'll just be doing advisory or community service or something anyway on Wednesday. So unique opportunity where I could flip 2 days, 2 assignments, and just give you a couple more calendar days. So hopefully that helps. So I'm not going to adjust that on the agenda because I verbalized it. So I guess if you're not paying attention, then I guess that's your punishment. If you don't, you'll come in thinking that the test is next class. But Okay, so I'm going to help out as much as possible, help you finish up with 36. So as always, if you don't have questions with 36, or if someone's asking a question you didn't need help with 36, you should move on to the next part, which would be 37, the test review. Okay, so I know we looked at a few of these last class, but most of you should have had to do a few more outside of class. And I think I have most every one of these worked out on the website, but I didn't tell you you had to have them finished, so. Sorry, give me just a second to update attendance. The internet was down when class started, so I couldn't put it in right away. Okay, so on this worksheet from last class, was there anything from the first page? Questions 1 through 6. The non-AP questions. Doesn't mean they're easy, but these questions were just made up by somebody else. Okay, now again, every class did some different, so I don't remember exactly. But what about page 2? Questions 1 through 4. Any of those that you tried and couldn't get? Okay, I'd like to save 6 for the last, because I told you to save that one for the last. It's just kind of a pain. But what about 5, 7, 8, or 9? Any of those? Yeah. 8? Sure. Now, as always, if this 8 is just one you didn't work yet, if you didn't have to have this finished, it's your choice. You can either follow along with me now, or you might need to look at the class recording or the class video of this question later. It's up to you. Okay, if the triangle shown above, theta increases at a constant rate, so the rate that theta changes is 3 radians per minute. At what rate is x increasing? So x prime is what we're trying to solve for. At the time when x is 3 units. Okay, and we're supposed to use this triangle up above. So, I know I have to include x in some kind of an equation, because how else am I going to get to plug in 3 for x and or solve for x prime? And I've got to include theta in an equation. So this isn't necessarily a geometry formula that you memorize like area of a circle, but it is still a geometry topic. You could set up an equation with SOHCAHTOA. We could say from theta, I want to include opposite and hypotenuse, so that would be sine, because sine does opposite over hypotenuse. And then this is the formula you need to work off of. The derivative of sine something would be cosine something, but realize you just took the derivative of theta stuff with respect to t, so we need a theta prime. Over here, this is like 1/5 times x, so the derivative of 1/5 x would be 1/5, but since we're taking the derivative of x with respect to time, we also need an x prime. And when you plug in 3 for this, you realize you're solving for theta prime. The last thing we need to substitute here is I need to make a substitution for this. I need to plug in theta here or make this replacement for cosine theta. So when x is 3, what does that tell me about this side?
4.
Okay, so what does that mean the cosine at that point is? We get adjacent over hypotenuse, 4/5. So 3 times 4/5 is equal to 1/5 times the answer. Multiply both sides by 5, and I would lean towards E. 8 is E. That's correct. So, like many of our topics, do you have to set up SOHCAHTOA equations often in calculus? No. You're going to have to do it a couple more times this year. But if you can't do it, then that's just one more time that you get a question that you're going to be stuck because you don't remember some of your past stuff. So, all right, is that good enough? Anybody else want to ask something about 8 before it goes away? Okay, anything else in the first 9 besides question 6? Okay, and what about 10 or 11?
We do 11.
11? Sure. So, one thing I like you guys to see about the AP questions, not just to get a real feel for the difficulty level that AP expects, partly so you don't just think it's me being mean to you, but also questions 10 and 11 are great questions where you can understand related rates, but they show you exactly what I mean by like trying to put twists and turns on the question. You can do 20 related rate questions in a row, and then 11 throw something different at you, like generic constant K, which just makes us have to really dig a little bit deeper. Okay, so 11 says, when x is 8, the rate which this is increasing. Now, the rate of this, to me, that sounds like derivative, personally. The rate this is increasing, so I would do the derivative with respect to time, which is why I have an x prime there, is means equals 1 over k times the rate at which x is increasing. So times the x prime. So what is the value of k? Well, if we want to solve for k, we've got some other variables here. I'm going to have to know what x is. Okay, that's not a problem. They told me what to plug in for x. K needs to be there because that's what I'm solving for. The other issue is I've got x primes. But notice how there's an x prime on both sides. So if I divide this side by x prime and divide this side by x prime, those just cancel out and go away anyway. So if this side is 1 over this stuff and this side is 1 over k, then k must be equal to this stuff. So our answer should come from 3 times 8 to the 2/3. But you have to know how to deal with these fractional exponents. The 8 to the 2 is squaring it, and to the 1/3 is cube rooting it. So you can either square 8 first and then take the cube root of that, or you can cube root 8 and then square it, whatever you think is easier. Order of operations is the same there. I would cube root 8 to make it a smaller number, 2, and then square it to get 4. So that's why question 11 should be E. It comes from 3 times 4. So you had to read this statement and come up with an equation. The rate at which, rate is derivative, is means equals 1 over k times x prime. 1 over k times x prime. Realize you have an x prime on both sides that you could just divide away. And then when you plug in the value for 8 that they said, you're able to solve for k. All right. Everybody okay with that? I don't know whose question that was, but it's fine. Okay, what about 10? Is that one y'all tried yet? Okay, let's go ahead and just all, before I get out of your way and let you try to finish up the last couple, let's just all go ahead and look at question 6. There were people in yesterday's class that figured it out. It's not that it's impossible, it's just that it's unusually difficult, and I wouldn't even be surprised if they just released this one just because people didn't do very well on it. Alright, so it's actually the latter type question that we've seen a lot of times. P is against the vertical wall. Q is on ground level. If the ladder is slipping down the wall, so here's the ladder. The ladder slipping down the wall. What is the distance RQ at the instant when Q is moving along the wall 3/4 as fast as P is moving down the wall? Okay, well, we've got to get some information out of this. So, first thing, when it says like PQ, it's talking about the hypotenuse. And you can keep up with PQ and PR and RQ and P and Q and R if you want. But one thing I hate about this question is I hate the PQ and R. My brain, maybe it's just me, maybe it's just my brain, but I'm just going to refer to them as A, B, and C. So when they're talking about P, I know it's A. When they're talking about Q, I know it's B. R would be C. And like RQ would be A also, but that gives me something to start off with. So I've got this, and I know it's Pythagorean theorem. I know to take the derivative and divide everything by 2. So I do enough of those questions, I can go through those steps quickly. But when I look at this, I know so little information. I know the ladder length is 40, and I know the length of the ladder is not changing. And that's about it at face value. So we need to use this clue. Okay, what's the distance of RQ? So to me, that's what I'm calling A. So if I can ever figure out A, that's my answer. When, and then interpreting this into more information, I always do a bad job with this, so I got to be extra careful. The instant when Q is moving, so that would be the rate of Q, is moving along the ground 3/4 as fast as P is moving down the wall. So how Q is changing is means equals 3/4 the speed that P is moving, P prime. Now again, I don't want to deal with the P's and Q's and having more stuff than I need. So point P is opposite A. So A and P are synonymous to me, and Q is opposite B. So Q prime is the same thing as B prime for me. Okay, so in this question, if we are trying to solve for A, I'm going to leave A in my equation. I guess I'll leave A prime as well. But for, I did this one yesterday and I'm already forgetting some of it. B, I don't know B, but instead of saying B prime, I could use this statement and change B prime into 3/4 of an A prime. That removes one of the things I wasn't going to know anyway. And hold on, let me see. Oh. Okay, I think I made a little bit of a mistake. Let me show you what I did yesterday because I think that'll just be a little bit quicker. It's along the same lines. Okay, so we had this. This is the actual statement that they gave to us. I said primes because I was thinking ahead a little bit. But A, what I called A, which they are calling Q, is 3/4 of B. So you could solve that for B. you could plug that in for B into Pythagorean theorem. And since you know C, that gives you an equation that only has A's, and you can solve that for A. I think I called these different on the first slide I showed you, but if this is what I'm trying to solve here, the B, then once you know what A is, you can plug that back into this and solve for what B is. Let me go through that again.
Yes, please.
Okay, so their statement that the instant when Q, what I'm calling Q, is A, so whatever the length of A is it's moving along the ground 3/4 as fast as P, so 3/4 of P, but I'm calling P B. That gave me this statement. I solved that for what B is equal to, and I plugged this back into the Pythagorean theorem. If this is A squared plus B squared equals C squared, here's A. Instead of saying B squared, I could say this stuff squared. So that would be 16/9 A squared. And in place of C, we could put 40, because we knew that. That gave us an equation that we could solve for A. So I did that right here. A is 24. And then once you know A is 24, you can plug it back into this and solve for B and find that length, which is 32. So I guess to me the two challenges to this question, what I always hate is, again, maybe it doesn't bug you, but the PQR just doesn't register with my brain. When they say find the length RQ, I don't want to think of it as RQ personally. I think it's complicated to do Pythagorean theorem with two variables like that together. So my suggestion to you is rename stuff to A, B, and C. Every time they're talking about B, call it B. Every time they're talking about C or R, you could call it C. And every time they're talking about Q, you could call it A. And then the second hurdle to me is getting that last statement, getting an equation out of it. Getting that out of their sentence is not easy for me, at least. But once you have that, you can solve it in terms of B, plug that in place of Pythagorean theorem, solve for A, substitute it back to solve for B. And B is what I called RQ, so that's why that was my answer. Now, I think I've mentioned this a few times, but on your AP exam, the timing, they give you 2 to 3 minutes per multiple choice question. So calculator questions, they give you 3 minutes on average. So when they give you 15 multiple choice calculator questions, they will give you 45 minutes. That doesn't mean that every one of those questions needs a calculator, but you can use a calculator on those. Non-calculator questions, you only get 2 minutes on average. So even if you know how to do this type of question, it's going to take more than 2 minutes. So they don't put really extremely long questions on the AP exam, but when they tend to put slightly longer questions, they balance it out with some shorter questions. Because so it's not like every question on the AP exam was this long that year. This one took longer, so several of the others should have been pretty short. But I don't want you to worry too much about 6. I do want you to just take the 2 tips I tried to give you out of it. Rename it to ABC, because I think that makes it easier, and just be extra careful with that last statement to get a little bit more information. Okay, let me switch back to our class. Okay, so I think we looked at each page, and it seemed like we'd kind of run out of questions, but again, you didn't have to have them all done, so it could be that you need help on the ones you had saved. So let me give you a few minutes to work another question or two, and then I'll come back and see if I can help again. But as you finish up 36, please move yourself on to 37. You don't need to wait for us.
8:34 on Tuesday.
We did not. No.
Okay.
We're out of tissue. I asked for more, but they haven't brought me in. Brown paper towels is all we got right now. All right, is there another one I can help with yet? Okay, keep going then. Y'all found something by now? Sure, that's number 5.
Oh wait, I thought you meant on the new page.
Oh. I can in a second, but let me make sure people don't have questions for this first. Number 3. This one? Yeah. Okay, so number 3, let me scratch this out so I have space to work. Number 3 certainly needs a picture, and they're hoping that after you make the picture you kind of recognize something from geometry. So you've got a 2-foot person or a 2-meter person is walking away from a street lamp that is 8 meters above the ground. Assuming the person's walking at a constant rate and the person's shadow is lengthening at a rate of 4/9 meters per second. So the light is coming, hitting the top of his head, and then that's making up his shadow. So the shadow is increasing at a rate of 4/9 meters per second. And from this information, we should be able to figure out how fast the guy is walking. So how many meters per second is he walking? So the geometry thing, it's not just like area of a circle this time. You have to recognize and remember that if you've got a right triangle that perfectly fits within another right triangle, they're sharing 2 angles, which means these 2 triangles are similar. What it means to be similar is that their sides are proportional. So we could make a ratio out of 2 and 8, small triangle to big triangle, as long as you do that with the other sides also. But be careful here. These are lengths and these are rates, so you can't mix those together, unfortunately. So you'd have to say, I don't know what this is, I'll call it X, and I don't know what this is, I'll call it Y. So 2 on the small triangle is like 8 on the big triangle, whereas X on the small triangle is like all of this X plus Y on the big triangle. It's not just Y, because that's just part of the big side. X goes to X plus Y. So this is the magical geometry formula that you have to remember enough of to come up with. Then you can cross multiply, combine like terms, simplify as much as you can. But of course this is calculus, so if you're not taking the derivative at some point, that's a pretty big red flag. I guess sometimes you don't have to, but it's 99% of the calculus problems need derivative, at least until next semester. So take the derivative of y with respect to time and the derivative of 3x with respect to time. Derivative of 3x is usually 3, but since it's with respect to t, we need an x prime. And since I'm calling this x, my x prime was 4/9. And since I called this y, the thing they were asking me to solve for was y prime. So the answer comes from 3 times 4/9, which would be 4/3. D. So the first part of this, again, it's the hardest part. I know you guys can cross multiply, I know you can simplify, I know you can combine like terms, I know you can do this little derivative as long as you're thinking about with respect to time and plug those things in. I can't make the first part any easier other than to try to show it to you a few times throughout the year. There's probably only 2 or 3 more times this whole year you'll have to set up this type of similar triangle for calculus. But this was an actual AP question, so sometimes they've insisted students to know that before they can even show that they know the calculus. So just part of how it goes. Okay, I'm going to go over to the test review for just a second. Tyler had a question. I think it was 5.
Yeah.
5?
It's confusing, like, the wording.
Okay. So this is really trying to hit home. Implicit and related rates have one big thing in common. Both of them are about taking the derivative of a variable that doesn't match itself. Implicit kind of implies you're talking about taking the derivative of y's with respect to x, which is why we always created a y prime. And related rates, we take the derivative of all kinds of stuff with respect to t, so we get all kinds of variables primed. This is just trying to focus in on that. They tell you what r is equal to. They're asking you, this means take the derivative with respect to s. So taking the derivative of 4s would be 4, bless you. But I just took the derivative of an s thing with respect to s. So the derivative of 4s with respect to s is just 4. You don't need an s prime there because those variables match. For the derivative of -5 sine r, that would be -5 times the sine of something is derivative is cosine of something. But for this question, I just took the derivative of some r things with respect to s, and that is not 1. This is not something divided by itself like this one is. So we've got a 5, we've got an r prime, and we've got a cosine of r. So I have found what they wanted me to find, but I haven't found it in terms of s only. So I need to rewrite this so that my answer is equal to this but only has s's. So I don't know what r prime is yet. I'll come back for that. But I do know what r is. Instead of saying r, I can use this guy. R is 3s to the 4th minus 1. And then, in fact, I can use this to find r prime. So derivative with respect to s, derivative of the right side with respect to s. I don't need an s prime because they were s's. So instead of saying r prime, we could say 12s cubed. So same thing, it's just instead of r's and r primes, we're replacing it with s stuff. So something like that would be a good answer. Of course, r's and s's are not as realistic, but again, it's just really focusing, trying to make you think about why do you need r primes in this question and not s primes in this question. Because if you understand why you need them for r's but not s's, that should be good news for you with implicit and related rates. Okay, while the test review is up, does somebody have another question for a minute? 7? Okay, 7's asking for second derivative, so I know that's going to be a little bit more work. I'm going to have to find the first derivative, and then turn around, and then take the derivative again. So to start off, this is implicit, because it's got all the x's and y stuffs mixed together. So I don't know. I've got to start somewhere. Try to give myself some space here. Alright, so the derivative of 5 would be 0. The derivative of -2xy would be -2 times the derivative of xy. So I'm going to have to do product rule there. It's x times y. Now this is telling me, you're starting to hopefully understand why they have to tell you this stuff. This is telling me I'm taking the derivative with respect to x. So taking the derivative of x would be 1. I don't need an x prime because I'm taking the derivative of x stuff with respect to x. So it's okay not to put an x prime. In fact, it's wrong to put it. plus, now leave x alone and take the derivative of y. Derivative of y with respect to x would be a y prime, equals the derivative of 7x minus 3y. Took the derivative of y with respect to some other variable, so I need a y prime. So before I can even begin to start thinking about second derivative, I need to solve this for the first derivative. So isolate the y primes, just decide to move them all to the left or all to the right. I just picked all to the right, it doesn't really matter. So that everything on the right has a y prime, and it can be factored out. And then you can always get rid of it with division. So there's my first derivative. In fact, this fact that everything's negative, I'm going to go one more step. I'm just going to multiply the top and the bottom by -1. Just change all those signs, yeah.
Wouldn't you distribute the -2 to x, y prime?
Yes, I should have. I'm sorry, this should have been distributed. So this should be a -2. So this would be a +2, which means this was a +2x, +2x, +2x. Okay, and now it would be a -2x. So, from that mistake, hopefully you see that it's better to go slow and steady than to rush through it, because a lot of times I may not have noticed that I had a mistake for a while. So, but all of that just to find the first derivative. But this question was asking us to find the second derivative. So now I can do the quotient rule of this. So derivative of the top would be 2y prime times the bottom left alone minus the derivative of the bottom, should be 2 times the top left alone, all over denominator squared. Okay, the one thing I am a little concerned about in this question, because it gives us some flexibility. It says in terms of x and y. So I don't have to try to get all of this stuff to be just x's or just y's. But as it stands, is all of this just x's and y's right now? What's the problem then? Right, there's a big difference between y and y prime. I know they almost look the same, but they're measuring two different things. So I can't quite stop there. Before I can say I actually have the answer, I must plug in what y prime is. Now this isn't a multiple choice question, so I'm not even going to try to bother simplifying it. I could care less about simplifying it other than to make sure that I know it's correct. But how am I supposed to figure out what y prime is?
You obviously have it.
Right, if you're paying attention, you had it already. You just have to plug it back in to meet their directions, because otherwise it's not really in terms of x and y. Now it's in terms of x and y. So second derivatives, always harder to deal with, obviously. But start off, it was implicit. Within implicit, there was product rule. After we got the first derivative, we had to take the second derivative, which used quotient rule. And within quotient rule, I had to do, actually I guess I didn't, okay. Anyway, you guys can see it's, all this stuff gets intertwined. If you're not good at quotient rule, then it's going to continue to domino for the rest of the semester in times you don't expect it, like this. Same with product rule. Okay. whoever asked that one, is that good enough? Okay. All right, let me go back to the one that's assignment 36, because I know not everybody is done here. You should be about done, but is there any more from this basic related rates worksheet I can help with? So just for my own information here, when y'all did this worksheet last class / for homework and stuff, I've been telling you the multiple choice questions were past AP questions. Were these harder than you expect? I'm not asking you if you think related rates are hard, because they just are hard for some people and not hard for other people. But were the multiple choice questions harder than you expected AP to ask, or about the same? About the same. Anybody think that they were easier than you expected?
It was harder. The AP questions were harder.
Harder than you thought they would have been?
Yeah.
And I know it's pretty intimidating at the start of the year, but I promise by the end of the year, as long as you guys keep trying each day, you'll get there. It'll be fine. So, okay, let me rest my voice here for another minute or two, and then I will offer, if there is anything else from this, I'll offer. Otherwise, I'll take even more questions from the test review.
Did you get an email from Miss Harmon?
I did. Are you done with your work?
Not yet, but like
Okay.
once it's like 10-ish. Can I
It
go?
depends on where you're at with your work.
Okay.
We'll see how much more you got to do.
I forgot to turn this in. Can I still get any points at it?
As long as I get it before the test, you can still get late credit.
Thank you. I never understood why TI was like so big, and finally heard just a couple months ago. It was like when they both came out,
at the same time. GI like did a lot of workshops to train teachers how to use them. And so then teachers, that's what they wanted to use, and all of a sudden they had to hold our hands. So Cassie had a really rough day. How's your brother doing?
Good.
Bless you. Bless you. Okay. This worksheet, that one, I think that was the only assignment he hated when he was in calculus class all year. It's the only assignment he complained about. Yep. Yeah, I don't think he was a fan of the ledger. But that was a long time ago.
I got one of these calculators.
We still got about 30 minutes, so obviously quite a bit of time to make some good progress. Is there anything well found I can help with? This worksheet or test review, either one. Number 2 on test review. So that is implicit. Okay, I know it's implicit because they're asking me to find the derivative and the x's and y's are mixed together. So again, this is very subtle, but you need to be looking at this and realizing I'm taking the derivative with respect to x. So when you do question 2, when you take the derivative of x, you get 1, but you just took the derivative of x stuff with respect to x. So you really get 1 times 1, and that's not a problem. Where it's important to keep up with is here, because the derivative of sine something is cosine something, but this time we're taking the derivative of y things. So we took the derivative of y with respect to x, and dy dx is probably not 1. Excuse me. Alright, equals, and then the derivative of the right side, you're going to have to do product rule. So the derivative of x times y left alone plus x left alone times the derivative of y. So once again, second time I took the derivative of a y, so second time I need a y prime. So that's the most important step to get to. Do you have any questions up to there? Okay. Alright, now the rest is algebra, so you've got to decide to move this y prime stuff to the left or this y prime stuff to the right. It doesn't matter. I'm going to subtract the y over, and I'm going to subtract this over. Subtract it over. And the reason you're doing that, which is the way that you're going to know to do that on the test, is now this and this both have a y prime that could be factored out, and as soon as you factor it out, you can undo times with divide. So I would expect it to look like that. And then I look at the answer. Remember, the answers are on the back page here. The back page doesn't have anything to work out. It just has the answers. So just like you've been doing, you do need to make sure that you get it simplified to the way they look as practice for multiple choice. So all they did was they swapped these two and multiplied the top by -1, and then they swapped these two and multiplied the bottom by -1. So those are equivalent. You just need to make sure that you know why, so that you know to pick this answer when you get that work. So truthfully, if you are studying or feel like you need to study implicit differentiation, honestly, it's probably one sentence that you need to make sure you have memorized. Every time you take the derivative of y with respect to x, create a y prime. That one statement is really enough to cover you for implicit. It doesn't mean that implicit is going to be easy. Realistically, if you're practicing implicit, you're practicing the derivative of sine stuff is cosine stuff. The derivative of something times something is product rule. You know, it's all the others, trying to isolate the variables, factor out GCFs. That's the stuff that really takes the practice, not so much that first statement. So if that's any comfort. Okay, can I take anything else from the test review yet? Yeah. Number 8. Okay, 8 has 2 parts. Which part would you like to see? A? Okay. And then we can do B later if you need to. So 8a. Use dy dx to find the equation of a tangent line at a point. Alright, so I've got one more person finishing up the second half of their test. Hopefully he's here today, and then you guys can come and see your test. I would say probably the most missed or second most missed question on your Unit 2 test was one about making the equation of a tangent line. Tangent lines are linear. To make a linear line, I would just always start off with point slope, personally. They tell you the point they wanted it to go through, 2, 3. So as long as you know the x value goes in for x1 and the y value goes in for y1, you're almost done. The only work that you have to dig in for is the slope. And on multiple choice questions, even if you just know this, sometimes you can narrow off a couple choices that don't make sense. So slope comes from derivative, so we still have to take the derivative of this. So x squared would become 2x. These are all with respect to y. xy, you'd have to do product rule. The derivative of x with y left alone plus x left alone times the derivative of y. I'll highlight it because I took the derivative of the y. Minus the derivative of y squared, which would be 2y, y prime because I'm taking the derivative of the y, and that would be equal to 0 because the derivative of the constant is 0. Now, if you've got options here, if you really want to solve for y prime first and then plug in the point 2, 3, that's mathematically fine, but anytime you're just plugging in a point anyway, I would just plug it in as soon as possible. Everywhere you see an x, plug a 2. Everywhere there's a y, plug a 3. And if you do that, you get a pretty quick equation to solve for y prime. It looks like the slope when x is 2 and y is 3 is 7/2. And 7/2 is not correct, so I got something wrong here. Oh, it was right here. I said 2 times y was 4. I plugged in x, not y. I should have plugged in 3 for y, which would make this a 6, which would make this a -4, which makes this a 4, which makes this a 7/4. Oops, 7/4. So, no such thing as being too careful on these question types. And then now it looks like the back. But I know you guys will get more comfortable with making equation of tangent lines as time goes on, but it does worry me that you guys did not do better on that type of question on Unit 2, because equation of tangent lines is going to come up randomly all year long. Start with point slope. The x value is always given to you. Sometimes you have to plug the x value into the function to find the y value. Sometimes it's just going to be given to you. The slope is always going to come from the derivative at that point. So when you do the one FRQ that you have to do on the test review, that's what Part B is referring to. Right? In an equation of a tangent line. Yes, sir.
I looked on the website and there is no thing going over derivatives to exponential functions because I missed that.
Yeah, it's on the class reporting.
Oh, I know what I'm saying is that there wasn't a hidden website.
That was from the start of the last class.
Yeah. I looked at it to try to get the notes, but I didn't see it.
Something's wrong with our internet today. It was not working this morning, and it's very slow right now. Okay, this is the website you have bookmarked for us.
Yes.
Top left is the class recordings. So, I think you're missing it from Monday,
Oh, I was.
or Tuesday, I'm sorry.
Yeah.
So, you click the Tuesday second period link, and it was the first thing we did on Tuesday. So, just click play and get till you get what you need out of it.
I was looking under the assignment number.
Yeah. Sometimes I'll put links to videos down here, but generally these are just like homework questions and in-class questions and stuff. So. I have to push y'all towards the class recording because if I just give you the easy out all the time, then you don't hear things like, so who's absent today? Nobody's absent, but if somebody was absent today and they didn't watch that and they just look at this agenda and they don't ask anybody what happened in class, then they think the test is next class, and the test is not next class. So, but in the future it could be that it's getting moved up a day instead of moved back a day. So that's why I like y'all to do the class recording, so you hear all the same stuff everybody else is hearing and we're all on the same page. Okay, y'all still got about 15 minutes, so if you find something I can help with, please holler and say something in the next 5 or 10. And about that time, I'll share the daily puzzle with you if you want to do that instead of keep working on your review. So again, on Tuesday, this is an A week, so I won't see you tomorrow. On Tuesday, the plan has been to do the test. Since I'm swapping that day and what I had planned for the next day, our test will be Thursday next week. So you're getting a full calendar week to review if you don't feel like you're doing well. But keep in mind, Tuesday's not going to be a full class, more time to do the test review. I gave you class time today to work through the test review. I'm going to have a circuit on making sure you know all the calculator things they expect you to know for your AP stuff, so that you can actually use your calculator correctly throughout the year. Yeah.
Can you go over number 6?
Mm-hmm. Okay, so this is very unusual. We're taking the derivative with respect to y. So the derivative of natural log of something is going to be 1 over the something. Now normally when I take the derivative of y, I need a y prime, but I don't in this case because it's with respect to y. Are you?
Okay, that's what I was going to say.
Yeah, because again, I don't like to write it out this way every time because it's calculus questions are already long and got so many steps to them. But really, we just took the derivative of y stuff with respect to y, and so this is essentially 1, and that's why you don't need it here. Minus, I'm committed now, so I'm going to finish. 2 times the derivative of cosine something would be negative sine of something. In this case, the something is v, and since I just took the derivative of v stuff with respect to some other variable, doesn't matter what it is, just that they're not the same, you need a v prime also. And then, so here is the derivative, and so I would normally circle this and say I'm done, but it says it wants it in terms of y's only. So 1 over y is already in terms of y, but cosine or sine v is not in terms of y. So instead of saying v, I can put what v is in terms of y cubed minus 3. And in place of v cubed, or I'm sorry, v prime, I would need to take the derivative of v So I would expect it to say something like 1 over y plus 6 y squared sine of y cubed minus 3, something like that. Yep, and that's what they got. So pretty unrealistic question, but again, it's trying to really force you to think about when you need the variable prime and when you don't, and not just hoping you're doing it correctly.
Yeah.
Just make sure you do the rest. You're good to go. You go back to yeah, check.
Would you need a y prime for the b prime because you took like
I don't because of this. I took the derivative of some y stuff. But it was with respect to y, so this was like 1, and so it's fine not to include it. It's only when you're taking the derivative of y stuff with respect to some other variable that you need a y prime.
no for 3y squared
Uh-huh.
for the didn't you need a y prime for that?
Uh-uh.
'Cause you took,
It's coming from this.
yeah, but you took the derivative b with respect to y, right?
Yeah, and so that became v prime. The left side, I took the derivative of v with respect to y, or you can just call it v prime for convenience. But over here, I took the derivative of y stuff with respect to y, and that's fine not to include because that's like times 1.
Okay.
This is what I was saying about making sure you're paying attention to the variables, because 99.999% of the time you're taking the derivative of a y, you need a y prime. But if you don't understand when and why, then there's times like this that you can miss that. If it's with respect to y, you don't need a y prime. In fact, it would be wrong to include a y prime. The variables have to be different for you to need the variable prime. The variables are the same, just like when we take the derivative of x stuff. We do what we learned the first couple weeks, and then we say, well, we took the derivative of x stuff with respect to x, so that doesn't really matter because it's like times 1. So if you're doing the derivative of y things with respect to y, it still works out the same, and dy over dy is still essentially 1. So that's why it matters so much about what you're taking the derivative with respect to, because it changes what you need. Okay. No, you have some.
The FP practice one, how do you approximate the value?
So you have to. So did you get the equation in part B?
Yeah.
Okay, so if you plug in 4.2 for x into that equation, and y in for, or k in for y in that equation, for part B, you have
Okay. Y plus 1 equals 3 times x minus.
right. And so this, so like we've got a curve, right? And this represents a tangent line. So what they're saying is use this to estimate. This is when x is 4. They're asking you to estimate where it is when x is 4.2. So if this was 4 hypothetically, 4.2 is right here. Do you see how the tangent line is almost where it really is? So to estimate, you're going to take this guy when x is 4.2 and y is k. That gives you an equation you can solve for k. So assuming it stays at that same slope, which it doesn't, but if you did assume that, and you only nudged over 0.2, we can figure out where that y value is. And we'll actually do an entire circuit on those type of questions. They're very common too. Okay, let me recap the directions here just to make sure we're all clear about where we need to be. So I need you to finish up 37. I would like for you to still move forward and prepare like the test is on Tuesday. Again, it does not help you at all to move the test on to Thursday if you don't take advantage of that time. If you just procrastinate your studying by 2 days, then it's all in a wash anyway. And I obviously can't do this very often, but you need to finish up the test review. If you know you need to practice more on implicit, I've got a couple links here on the bottom of your test review that you could do that. If you know that related rates is your struggle, I mean, some related rates are just hard, but if you know that you're really weak at those, there's about 10 different links you could practice, some easier ones to harder ones. And make sure you spend at least 30 seconds looking at derivatives exponential functions. The 37A, remember, that is optional, but when I make up your FRQ for your next test, I will make sure that most of the parts of that FRQ come from most of the parts of those optional ones. So those of you willing to put in the time and effort to do some extra work will be rewarded by the FRQ being a little more familiar to you. So that's the only way I can incentivize you, I guess, to put more effort towards free responses. So. Okay, so all that's the most important, of course. Is there any questions about what's due next class, what your homework is, when the test is? Any general questions like that? Yeah. Keep the review for now. I didn't take up any assignments today because, again, I was planning on testing next class. But, of course, I will take up some of our recent assignments. So just make sure you keep them in your binder, and then it shouldn't be an issue. So. Okay, did y'all do the 8 small puzzles last time? Those?
Yeah.
Okay. Then here is my newest puzzle. And my classes yesterday discovered that it took a little more thought than, the more you think about the question, the deeper it gets. So. But I will share this one on Google Classroom. There's a website where they explain the answer. So if you want to know if you did it right or want to know how you're supposed to figure that up, I will send that to you in Google Classroom. Oh yeah, if you borrowed one of my calculators, I need it back too, please. Anybody got a guess how many races?
Count in your head.
Count in your head. No, you need more than 5.
The other 66.
Well. So the problem with 6 is you got to do 5 races, right? At least. to see the top 3 in each group. But what if the 4th fastest horse in race 1 is faster than 3rd place in race 2?
11.
You can do it in less than 11.
Well,
Yeah,
you don't
just
need
guessing.
to. You just cut the. You do 5 races, and you take the top 3 from each race.
Yep.
So that'd be 15.
Yep.
Then you do another 3 races. You take the 3 from that thing. You have 9 left.
Okay. So you're up to 8 races.
Yeah. And then you have 9 races, so you do 2 and take the 3 from both.
You don't sound very confident anymore. You guys want to know
I'll
the
scan
answer?
it through as I'll say on it.
The answer is 7. You do it in 7 races. But if you want to know why, it's on Google Classroom.
Can I pause it for not doing it? Sure. I could probably do it.